Okay, so we have a question here. A collection of 33 coins consisting of nickels, dimes, and quarters has a value of $3.30. If there are 3 times as many nickels as quarters and 1/2 as many dimes as nickels, how many coins of each kind are there? So we've got a kind of question that gives us a lot of information here, and we want to decide what we're going to do with it. So let's start by writing down what we know. We know we have nickels. We know we have dimes. And we know we have quarters. We don't know how many of each of those we have, so we're going to assign variables. Although we do know that in total, there are 33 coins. So that's interesting. Unlike many problems, we found out how many actual coins we have, along with other information relating them to each other. So it tells us there are 3 times as many nickels as quarters. So the thing that things are being compared to, that's the quarters here, we will set that as x. But there's 3 times as many nickels, so that is 3x. There are 1/2 as many dimes as nickels, so that is 1/2 of 3x. And of course we could simplify that and say it's 1.5x or 3/2x. Fractions are sometimes nice, so I'm going to write it as 3/2x. But we could think of it as 1.5x as well. Now, we already know that this and this and this together give us 33 coins. So we already have enough to set up an equation. We have 3x and 3/2 of x and x being equal to 33. Okay, so how do we solve this kind of algebra? Well, there's a few ways we can do this. We can just deal with it, not worry about the fact that there's a fraction here, and just put together 3 and 1.5 and 1, and it gives us 5.5 x's equal to 33, and then we could divide by 5.5 because that's our coefficient in front of x. That's not an overly nice way of doing it for people that aren't comfortable with fractions. Instead, you could multiply everything by 2. That means everything on this side and everything on this side by 2, and that would get rid of fractions. We would have to remember to distribute and multiply everything here on this side and on this side. But that is nice in that it gives us 6x plus 3x plus 2x equals 66, and we no longer have any fractions. So that might be nice. So 6 and 3 is 9. 9 and 2 is 11. X's equal to 66. Divide by the numerical coefficient, and we get x equals 6. We can then plug that in to our original information here and actually say, well then, this is 6. 3 times 6 is 18. And 3/2 of 6, 1/2 of 6 is 3. 3 times 3 is 9. And those do, in fact, add up to 33. So we did this question without ever having to use the value here, which is interesting because we're used to having to use that. We could use this to check our answer now and make sure everything works out with the numbers we have. Or we could have done the question a completely different way in the first place, if we didn't know the total number of coins. We could look at this question and say, I don't know this information anymore. I've got 3x nickels Each one is worth 5 cents. So I've got 5 times 3x being the value of my nickels. I've got dimes that are worth 10 cents each. And I've got quarters that are worth 25 cents each. And we could simplify these. 3 times 10 is 30, and half of that is 15. Wait. Should we get the same amount here? Oh, so we can't get the same amount because that's the value. Okay, and 25x. Okay. So we know that the total value of all these is 330 cents. And now we have enough to make another expression that we could solve for. We have 15x and 15x and 25x being equal to 330. We combine like terms. 15 and 15 is 30, plus another 25 is 55. X's equals 330. Okay. I don't have a calculator on hand, so doing mental math, I can notice that there is a factor of 11 in both these things. So I'm just going to kind of reduce. I'm going to divide both sides by 11 first because I'm doing mental math here. Now I can kind of see a little easier what to do. If we had a calculator, we would have divided both sides by 55 right off the bat. So x equals 6. Just as we solved the first time, we would take that 6, plug it back in, and get our answers of 6, 9, and 18 for the amount of coins. So there were 2 ways we could do this problem, and they both work.